Hello there, I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX in tonight's flight. So right now I'm in the cockpit of the Boeing 777-300 ERX. I'm gonna show you the cockpit instruments of the Boeing 777-300 ERX of the PNG simulation. So I'm gonna show you things like the primary flight display with the airspeed and the barometric altitude displayed, the magnetic through heading, the speed and the flight guidance of the aircraft using the flight director or the autopilot in the horizontal situation indicator, and the primary flight display. Besides the airspeed and the barometric altitude, we have also the rate of climb and descent. We have the modes selected with the auto thrust and the autopilot, and also the selected or the managed airspeed and altitude of the autopilot panel of the AFDS or the pilot and flight director system. I'm also going to be showing you the navigation display with the terrain map, with the nav aids, the VORs, the airports, the other traffic displayed by the TICA system, the traffic collision alert system. We have the radar display from the ground and the clouds and the weather, like turbulence and wind shear. We have also, as I said, the autopilot and flight director system with the dual auto throttle and the autopilot, and also we have the modes of the speed guidance, the speed hold, the lateral and the vertical navigation, the altitude hold, the altitude select, the heading select and hold, the airspeed heading, the airspeed select and hold, and also the flight level change mode, and the rate of climb and descent. We also have the ACAS, the upper and the lower ACAS system, the engine indication and crew alert system of the aircraft with the modes displayed from the engines, the N1, which is the low speed, low pressure compressor stage of the turbofan, turbojet engine, the exhaust gas temperature, the flaps and flat setting, the messages from the ACAS, and we also have the N2 in the lower ACAS as far as the engine indications, which is the high pressure, high speed rotor stage of the turbofan, turbojet engine. We have other settings like the fuel flow in thousands of kilograms per engine per hour. We have the vibration from the engine. We have the oil temperature and quantity. We also have other systems in the overhead panel, which also display in the lower ACAS, like the electrical with the IDT, the drive generators, the 75,000 kilovolts to 45,000 watts of electrical alternate current each engine, left and right engine. 115 volts, 400 Hz frequency, alternate current. We also have the APU, the auxiliary power unit used for that. We have the standby electrical generators. We also have the batteries, 38 volts each with about 47 ampere hours. Its alternate current can be converted into direct current using transformer rectifier, and the direct current from the batteries into alternate current using a static inverter. We also have the hydraulic systems, the left and right engine hydraulic systems. We have the C1 and the C2 backup electrical engine compressor. We also have the ADIL, the air data inertial reference unit, that displays the air data from barometric and also GPS and other factors like airspeed, barometric altitude, and angle of attack of the aircraft, and magnetic and through heading from the compass. And it displays all this data in the primary flight display, navigation display, ACAS, and autopilot flight director system, and the flight management computers also. We use the flight management computers to create a flight plan for the aircraft to follow using the autopilot and the autothrust system. We also have in the overhead panel the engine start, automatic auto start or manual start. We have We have selection for that. We have also the electronic engine controllers for the fire exit, the engine control. We have other systems like the fuel tank, left and the right wing fuel tank, and the center tank, and the pump, the forward and the aft pump. And we also have the APU feed from the fuel tank. We have the X feed for its left and right wing tank, using only one pump from one tank, using the X feed valve to supply other one. We also have the cabin pressurization system, the lighting system, the engine eyes, left and right wing and engine. And also we have in the cabin pressurization system the manual with the automatic modes with the outflow valve controllers and the landing handle selection for cabin pressurization during flight and cabin pressurization during descent. We use the controllers or the automatic mode. We also have the left and the right engine compressor from in the overhead panel display in the aircraft, and this supplies a compressor from the left and right engine and the APU for engine start using the engine starters, which I'm gonna show you all these systems. The compressor system that supplies the cabin pressurization, the air conditioning, the wing and the engine RPIs, and also the hydraulic fluid tanks. We use the hydraulic pumps and tanks for pressurizing hydraulic, like the flight controls, the ailerons and spoilers, the elevators, the stabilizer trim, automatic or manual, and the rudder, using the rudder pedals. We also use it for the nozzle steering and the ladder gear extend and retract, and also after reversing the engine start reverses. So I'm going to show you all these systems using also the control column and control wheel, the yoke as we call it in the Boeing terms of the aircraft, that controls the elevator and the ailerons and the spoilers, and the rudder pedals. This is part of flight controls, the speed brakes extend, and also the stabilizer trim position switches, and the flaps and slabs flap lever. I'm also going to show you systems like the thrust levers, how to use thrust levers to modify the thrust during flight, and the communication panel of the aircraft using its radio navigation communication systems, and the transporter pickup system for the traffic collision radar system, and also the weather and terrain radar and some other systems in the communication panel. So we have about an hour and 10 minutes to go, so let me start right now this flight, maybe less than 1 hour and 7 minutes. So thank you very much for joining me. As I said, I'm Thomas Hatsios, the pilot captain flying the Boeing 787-85. We're going to be overflying Zurich and Switzerland and Germany, and then coming back to Zurich and Switzerland for landing in the runway 14 again. So I'm going to start right now showing you all the systems of the Boeing 777. I'm going to make an engine start demonstration and set up the flight management computer platform. So thank you very much for joining me. So let me start here. I'm going to show you first the flight controls, using control column and wheel, control wheel, the yoke, as we say in this aircraft. So you can see a pitch up and pitch down the elevator of the aircraft. So you can see here I'm having the control of the stick from the Airbus, and I'm using it from the Boeing this simulation. For this flight there is no problem with that. So you can see there is a proportional movement of the control column and control wheel, the yoke, as far as it concerns side stick, and also for the ailerons and the spoilers, and for pitching up and pitching down, and also for the rudder, and the stabilizer trim position, the flaps position, and the thrust levers. So you can see here pitch up and pitch down the aircraft. Also we have the display here of the flight controls. In the menu, have it on. So you can see the flight controls position here. Maybe I'm gonna extend the flaps to show you the flaps lever all the way down to the 30 degrees. You can see the flap position requested is here 30 degrees. The flap is still in transit, it's going down. It's about 5 degrees now, so you can also see I can extend the speed brakes here. Thus the display will show you the speed brakes, this display. Also the spoilers and ailerons, and the spoilers, the ailerons, the flappers here, left and right wing. You can see the engines of the aircraft, the Boeing 777, the elevator position, the rudder position, and the stabilizer trim and the rudder trim. You can see the indications are normal. So we have about an hour left for this flight. I'm gonna show you the rest of the system. I'm gonna show you some of the flight controls, how to use the side stick for the flight controls, the control column and wheel or yoke as they call it. So I'm gonna start with that now. You can see here we have, as I said, the stick, so we pitch up and pitch down the aircraft, the elevator, the ailerons and the spoilers, the rudder, pitch up and pitch down the elevator, and also the thrust levers here. You can advance with this traveling, you can see all this here. We also have the outside view of the aircraft. You can see the ailerons and the spoilers here. Position, left and right. The elevator pitch up and pitch down. The rudder, also the rudder position here. So you can see the elevator and the horizontal stabilizer, the rudder, the vertical stabilizer, and the spoilers, the flaperons, and the ailerons here, the outboard ailerons. So you can see how I use the stick, the side stick to control the flight controls. The elevator picks up and picks down. The spoilers, bunker left and right, picks up, picks down on the stabilizer trim position. So I'm gonna show you now inside the aircraft the rest of the system and how to make an engine start. So we have 1 hour left for this. So we have right now 1 hour left for this flight. I'm gonna show you now the overhead panels, the displays, how to make an engine start, and how to set up the flight plan for takeoff. So thanks for watching again. Hope you have a nice video. This is so much for the flight control version. We're gonna make the rest of the flight display now. So you can see here we have the primary flight display, the airspeed selected, the altitude, barometric altitude above sea level, and the barometric altitude selected, the altitude selected from the autopilot. We have the takeoff go around here from the flight director on, and the pitch altitude for takeoff in decrease. that we're gonna use for takeoff. The ground speed is 0, the magnetic heading, and the radio altitude here is pitch ladder in degrees, and the bank angle. So you can see here the navigation data, this is more rear data, and autopilot and auto thrust data, and the flight guidance of the aircraft. So this is the navigation data. Now it displays the airports and also the terrain map display with the radar. You can see the radar scanning here now. The ground in front of us with yellow, green and red. So this is the standby instrument. This is the FS panel. This is the autopilot flight director system. So we can set a different airspeed, for instance like 250 knots. All these switches are depressible, as you can see in the autopilot panel. The heading also. I'm gonna set the runway heading. You can see we can depress this switch also. And the altitude, I'm gonna change the altitude to a higher level. We also have this depressible switch, like 35,000. We can use the altitude on this whole switch. Have to increase this again. We can use the autopilot now, and we have the autopilot message here. The autopilot with heading, hold and altitude connected. We can disengage the autopilot using this switch. You're gonna see the light here, the disengage light. You can engage it again, disengage. So stop this warning here and set it back. You also have this is the vertical speed of the aircraft. Now it's descend, now it's climb, like 1,500 feet per minute. You can see the heading, the airspeed, the vertical climb or descend, and the altitude select. So we select the hold here. You can see the autopilot connect. We have some settings from I'm gonna show you as far as I can, So you can see here is the overhead panel, the left and the right engine, electrical IDGs, the brake drive generator, C1, C2 backup, and the APU. So maybe we're gonna use the APU now for starting the engines. So I will lower this. So maybe I make first the engines demonstration. We have the modes here, the engines. So you can see what the engines display now. The N1, the left and right wing engine. The pressure ratio of the low pressure, low speed compressor stage of the turbofan turbojet engine. The exhaust gas temperature in Celsius degrees. The duct pressure from the packs. From the bleeds, from the engine bleeds, intermediate high pressure bleed stages, and the forward and the aft for the cabin pressurization of the outflow valves. This is the N2, which is the low, the high speed, high pressure compressor stage of the turbofan turbojet engine. We also have the fuel flow in thousands of kilograms per engine per hour, the oil pressure or temperature or quantity, vibration of the engine. We have the flight management computers here, left and right, and the third one, a backup one. We use this to create a flight plan. I'm gonna show you here. So we set, we need now to set the engine status. You can see the hydraulic pressure, 3000 psi, the quantity, left, center, and right, and we have the APUs off. So if I come in this view, so you can see the overhead panel. You can see most of the cockpit actually now. So we have about $55 minutes left for this flight, so this is good. So you can see here the panels, you can see the autopilot I was showing you now. You can see the switches. I can depress this switch or it change the value. You can also set the autopilot on. You see here is the autopilot connect. You can see the autopilot message. Here is the autopilot disconnect. Now we have the warning here, and we have the flight director here in the message. So we also have the heading here, hold switch, the altitude hold, the vertical speed, descend or climb with minus or plus sign at 2000 feet per minute. You will see here the vertical speed in the heading hold. You can see the airspeed now and the altitude is different. So maybe I'm gonna make an engine start demonstration now. You can see the flight level says LNAV and the VNAV. We have the auto thrust here. You'll see auto throttle left message. So the left is off. Flight director on and off. I'm gonna hold this and press this button. So you can see I'm also having here, this is the automatic trim cutout seats for the horizontal stabilizer, the horizontal tail of the aircraft. You can see the degrees here, and this balances the aircraft inside. You can see we have the normal, all the cutout, the C and the right system. So we leave this in the normal for the autopilot and the auto thrust. You see the pitch trim here handle. You can see the speed brake here, and extend the speed brake so it's right. You can see the flaps position here in degrees. You can see how many degrees here. We have it in the 15 degrees now. So this is good for takeoff. We also have the fuel flow for the engines and the thrust levers of the engines. I can move it forward. You will see the engine increase. So I can move them back into the idle. Extend the speed brake. So this is the overhead panel, as I said. This is the electrical, you can see. The battery, the APU generator, the APU on and off. So we're gonna start this, the APU. You're gonna see maybe a message, a full message. We have the left and the right engine IDG, so we're gonna leave this right like that. We can turn the IDG so the bus ties on and off, the APU generator on and off. That's gonna leave for this right now until we're gonna have the APU on. So maybe we can see the APU is almost on. A few more seconds, you can see it's increasing. I was showing here is the left and the right engine IDG. We can disconnect them here using these switches, but we're gonna leave them the way they are. The backup generators and the contactors. For the alternate current, this way, and the direct current this way, the other side. So maybe I have time, I'll show you also here. In this display, we have also the checklist, normal menu. You can see we have the pre-flight, what to pre-flight, oxygen. We have the normal menu. Before start, we have many items here. Maybe I'll show you in this view. So you can see the items here of the lower ECAS of the checklist. So the checklist is complete for this item and the flight management computer. So before takeoff, the flaps. So we also have the resets here for the ACAS. In the normal menu, like we have a fault, like an auto throttle left, auto throttle disconnect. Automatic flight, the autopilot, what we have a condition in the autopilot, like a fault. So we have in the engines and the APU. So you can see the engines and the APU. If we have the left engine fail, what to do? We have 1, 2, 3, 5, 6 items. The objectives, what to do, objectives. Item 4, item 5, item 6, maybe have more than that. So we go back into the normal menu. So this is for the computer settings. So we have also the communications. We have the synoptics. We have the doors here. You can see the doors are closed, so we can pressurize the cabin, the gear. You can see the pressure in the tires and the temperature. We have the electrical, the left and the right engine. The green is the flow. The white is no flow, and the green also is the APU generator on. And we have the voltage from the battery, as you can see, the left and right. You can see this is the symbol of the compressor of the integrated drive generator, an alternator symbol. Left, right, and the right engine, and the electrical backup generator, electromagnetic generator. So you can see the contactors here. You can see the hydraulics here in this page. We have the left and the right engine and the backup. So you may see C1 and C2 backups, and we have the flight controls, the radar, we have the nose wheel and the landing gear, external track, we have the fluid quality, the hydraulic fluid, and the PSI, pounds per square inch, 3000 PSI. You can see with green is the flow, with white is no flow. We have the primary demand. We have also the fuel, pumps and forward and aft, and the fuel line. From the left tank is for the APU and the left engine. From the right wing tank is for the right wing engine. So we have also the sender tank and pumps, but it's off because there is no fuel right now. We have the crossfeed valves also. We have about 30% fuel. We have total fuel here to be 47,300. You can see the left and the right engine, the APU feed with green line, and with white is no feed. The crossfeed is on. So I'm gonna turn on the crossfeed. I will show you now the crossfeed on. So you see here is the electrical I will show you. The hydraulics here, the left and right wing engine. I will show you later that. We have here is the crossfeed. We have on and off the pumps. We have also the dumping fuel here. We have the nozzle. We have the left and right wing engine, electronic engine controllers, normal or alternate modes, and the engine start, auto start here on and off. So you can see the pumps here also. If we have the crossfeed, we can use only one pump to supply all. Now it's only one pump working. The left wing pump, you can see the green line feeding both engines on the low and the high pressure fuel valves, while the right wing engine is off. Right wing tank pumps are off. So it's the crossfeed line from the left engine to the right. So I'm gonna show you again. Over here, upper panel. So we're gonna use the correct mode for that. You can see here is the RDIs, wing and engine RDIs. Here's the hydraulics, the mount pumps, electrical on, and then to the auto position. We have also these switches, switch on and off. The hydraulic pumps. We have the window heat. As I said, primary flight computers, the ADIRU, the Air Data Inertia Reference Unit that displays the terrain GPS data, the airports, the barometric and anemometric data for the airspeed and the altitude, the radio altitude, magnetic truth shedding in the autopilot and displays, and also in the flight management computer and the auto track. So this is very important instrument. I will show you maybe in another slide how to use it, because we have less than maybe 40 minutes for this slide, 45 minutes. So we need to hurry up. So use the electrical. Maybe we'll make a reset. You will see the ADIRU working. So this is the ADIRU off. You can see now it's off, not working. So there is no display here. Using this button, the display is off. Very important. You can see we have off the heading and the altitude. There is no autopilot now. Navigation ADIRU Air Data Inertia Reference Unit, Inertial SATCOM, Data Link, TCA, SATCOM, SAT Voice Loss, no auto land, display select. So we have a lot of systems lost using the ADIRU. So we reconnect the ADIRU is on, and we only need here is to do one last thing, hit virtual cockpit. So we need the ADIRU here to set the position here in the FMC. You can see the model, the Boeing 777, last position or GPS position. You can see we have no data here. We lost everything because of that. So we connect this the ADIRU using the GPS position, and the gyroscopes of the ADIRU are going to align the aircraft heading. Here we are, having the radar back on. We have a fast alignment mode. So we're almost ready for takeoff here. Show you most of the system. Let me say a couple more. So this is for the engines, the ADIRU, the display. We left only a couple of things. We also have the air system here. You can see the left and the right engine symbol. CDU, you can see here. We have the left engine, the right engine, the engine starter, the APU. The APU is off because we have this white line right now, so the valve is in the off position. And there may be the high pressure compressor of the engine. This is the engine symbol, compressor for the air conditioning, for the cabin pressurization, for the wing and the engine anti-ice, for the hydraulic fluid, for the flight controls. So we have no flight controls without this compressor from the APU or the end. So this is so much for this lesson, I believe. We have about less than 1 hour, maybe We have about 40 minutes left, so I'm gonna show you very quickly the overhead panel, a few more things, and do the engine start. Overhead upper panel, I told you about the electrical panel, the Adiru, the flight control computers, other systems, the hydraulics, the fuel system, the fuel dump, the engine controllers, the FADEX full of our digital engine control computers, cargo fire here, crew and passenger oxygen here, air conditioning here. So here we have the fuel tanks and some other system, and the cabin pressurization, forward and aft, manual or automatic. The controllers, if we use manual pressurization, and the landing altitude. So you hear the message. We close the outflow valve. So here is also for the engine start. We can use the compressor as I showed you before, left and the right engine. Now it's off, we have only the APU feeding the line. So if we're gonna make an engine start for the left engine, we're gonna turn off all these switches. We do a manual. I'm gonna make an automatic, so we're gonna turn back this on in the automatic position, as you can see. So this is for the overhead panel, the autopilot, navigation and communication system. So we have a nice view here of the cockpit, as you can see, of the Boeing 777. So we have 20 plus 18 minutes left, 38 minutes. So we go back into the virtual cockpit, turn off both engines, fuel controllers here, turn both in the off position. So you're gonna see the engines slowing down. We have lost also the electrical on the engines, so you can see no fuel flow is zero right now. I'm gonna make an engine start, auto start. Hopefully we're gonna make it for about 30 minutes. So you can see here we have the left and right wing engine. It's not spinning now, slowing down, a little bit spinning. Left and right wing engine. You can see left engine here. So we have the overhead panel, its reconfiguration here. You can see the off message for the electrical here, the brake drive generators, one of the... So we have zero now for the engines, no spinning. So we're gonna use this auto start switch for the left engine in the start position. So we're gonna have the compressor, as you can see, the engine bleeds, the left and right engine bleeds, and the packs here going off automatically. The hydraulic here also goes off, the right wing engine. So we have the N1 here. You can see the N2 above 20%, but fuel flow is zero. So we only need to start the left wing engine. Now you can see start spinning. We only need to do the start. You can see it has started spinning. We have an N2 above 20%, which is acceptable for letting the fuel flow, low and high pressure fuel flow increase. We have the FADEX working. So you're gonna see here now the fuel flow is boxed and is above zero now, and also the N2 increasing. So you're gonna see the engine spinning faster and faster. Here we go. Now we're gonna start the right wing engine here. There is no spinning yet. We have a few more minutes left to go. So we're gonna use the overhead panel of the right wing engine start auto start mode. So you're gonna see pretty much the same things for the right wing engine now. We have 3 minus 4, 16 plus 18 minutes left. You can see the N1 increasing, the N2 also above 20%. The fuel flow 0 for the right wing engine. So you can see the right wing engine here start spinning now. The left wing is on, the right wing is only need to be started. So you can see the spinning start. You can see the wing, the right wing. So we go back inside and start the right wing fuel flow now. So you're gonna see the fuel flow increase rapidly. We have a fuel flow of 0 right now, so it's gonna increase rapidly alongside with the N2, and you will see the outside view of the right wing engine turning on. Here we have it, the right wing engine on. So we can start now for takeoff. We can proceed. You only need to set up the flight plan using this display, the flight management computer. We have the autopilot set for the takeoff. We need to set up this. Initialize. You can set the 0 fuel weight. You can see here 0 fuel weight, gross weight, and the fuel calculation for the takeoff speeds and the flight speed also of the aircraft. During its flight, it's reserves, 5% reserves, cost index 100, flight altitude 35,000 feet, center of gravity cruise 7.5%. So we have the origin and destination from Lszh to Lszh. Runway 14. Initialize legs departure. So we use this departure here. Increase the brightness a little bit. So we have this departure runway 14. Route to Alpha. So you can see the flight plan is being created here. I'm gonna show you later. We have the legs, departure, then arrival, ILS-14, trans this arrival, 91 Alpha and Transamiki. So we have the legs, and activate and execute. So we have enable cruise altitude, flaps 15, center of gravity here 36%. So we have most of the data. We have a few more minutes to go for this flight, so I'm gonna show you now the flight plan being created here. You can see the whole line from takeoff to landing and the runway heading here. You can see the fixes, the waypoint. We're gonna fly this way, then back to arrival. You can see the modes here with the flight director here on. There's so much for this. We have the V speeds on, 133, 141, 155. The takeoff, thrust limit, center of gravity here, trim flaps 15, 4 degrees, takeoff reference. V1, V rotated V2, 155 knots. So we set here the trim position. We can set it using this trim switch here. We have a trim switch for the stabilizer. We also have the auto thrust disconnect here, and we have also this lever is the thrust reverse. You can see the reverse thrust here. So we have the thrust reversers here. We can turn off, we don't need them right now. So we go for takeoff now. We have set everything. The center again. We only need have about 28 minutes for this flight, so advance the thrust levers and disconnect the parking brake and go. We're also gonna use this tiller for steering the aircraft in the ground. We have no traffic around there. So we use this tiller to steer the aircraft in the ground. We're in the runway. We have a few more minutes to go. So you can see where we are right now. We have a beautiful view here. We're in this runway and core. So we advance, set this to a lower setting just to have a better view of the flight plan. This is the terrain map. We set the thrust levers to a higher dimension, so you can see the thrust increases. We have the autopilot in a good position. We have also the ILS here and the radio altitude, the airspeed, the altitude, the airspeed select and the altitude select, and latitude setting, and the ILS localizer. So we can disarm the parking brakes and go and advance the thrust levers even forward. You only need to set the flaps down, 2 notches down. So you can see here the airspeed increases. We have V1, V8 and V2. We pass this V speed. So we go back into the cockpit. We have positive rates, so we got the landing gear. You can see the radio altitude here, 2,500 feet. The rate of climb, I'm gonna just increase the rate of climb. It tracks some flat. The climb so high now. So you can see the airspeed, the stall speed is Mach 0.4 right now. Flying with 2,500 feet per minute, 6,000 feet above the sea level. Maybe we track a few more flaps. We don't need so many flaps right now. So we set the speed and the I use the LNAV when you fly direct into a waypoint. Just fly direct to the... have about 35 minutes to go for this flight. We'll keep flying manually. I'm gonna set the LNAV now. So you can see the modes now are the speed, the LNAV and the altitude. All modes. The rate of flight 3,000 feet per minute, the airspeed, the Mach speed, magnetic trajectory. We have the waypoints here we have to fly, the flight plan. I'm gonna show you later. We have an aircraft here in front of us, plus 9,900 feet. Here it is, in front of us, over here. So here is all the aircraft, our spacecraft tonight. You can see the galaxy here as we overfly. The Boeing 777. Past 17,000 feet. Hope you enjoyed this view, the Boeing 777. We passed 19,000 feet right now. So I'm going back into the cockpit as we climb through 19,000 feet. We have 18 minutes left for this flight, so maybe we're gonna get back into heading +1 plus a few seconds. 19 minutes. So we have 1 minute to go. Need to climb a little bit faster. Higher rate of climb, 31,000. So you can see the auto thrust disconnect here. I use this button and apply manual thrust. So I'm gonna use a little bit more thrust, more airspeed. Climb a little bit faster. Have a few more minutes. So we climb up and we have like 18 more minutes for this flight. We're 33,300 feet now. 33,500. So we have the lake here. We overfly the lake. We also have the chemtrails now and the contrails, as you can see. Here we are. We also almost reached our climb altitude. So I'm going back inside. We are 35,000 feet. So we're gonna level off now. Maybe we track some flaps. Also connect the auto thrust. Using an automatic thrust now. So you can see we hold off manually the aircraft. We have not much time left. We have 18 minutes left only. So we need to start turning back in a while. So here we are, 35,000 feet. We have the chemtrails, as you can see. The vapors from the engine. As we're trying to hold level here. We're going back. Now going back into the airport. So you can see we have Germany in front of us. We have Munich and Bayern area and Bavaria. This is the Munich in front of us. So we're turning back to the airport. Manually. Using the flight directors. We have 12 more minutes to go. -3. 15 minutes actually. So we need to go a little bit faster this time. So we need to turn back very fast. So this is our spacecraft for tonight. The Boeing 777s have beautiful views now over here. You can see how we turn back to the airport, only 15 minutes left. So we have 14 minutes left for this flight. Here you can see how many nautical miles away we are from the airport. Maybe we're gonna make a shortcut. Still flying manually. Maybe I'm gonna connect the autopilot now here using this button. There's this switch here. So we only need to fly direct into the airport. This is much higher airspeed actually. I'm using a direct to waypoint. 14 minutes left, so we need to make a shortcut here. As we're gonna fly over with just 53 nautical miles away. 14 minutes left, so we are very tight right now. We're gonna make a big shortcut. So we have 12 minutes to go. Hopefully, we're just gonna make a descent on that fall and landing. "47 nautical miles away, we have to start preparing for descent. So maybe we're gonna use a lower altitude, 6,000 feet, less airspeed. So you can see the airspeed now is 0762 Mach. 055 Mach is still at 35,000 feet. So start descent, maybe using the flight level change. We're gonna have the descent. I'll use a speed brake here. And we have we have 10 minutes to go actually. So we need to go fast, we descend fast. Maybe use a little bit more airspeed. To descend with 4,300 feet per minute to 6,000 feet. We have only 36 nautical miles away to go. You can see that. 19,000, Mach 0.6, our speed right now. Then we also set this the airspeed for landing 35 degrees. So we have 9 minutes to go. I think we're gonna make it just in time. Ready to do a shortcut, 15,000 feet right now. This is how beautiful this cockpit is. If I'm gonna turn off the light. So this is the night view of the Boeing 777. feet. Keep descending. Across the lake again. So this is our spacecraft for tonight. We have all the star signs in the Boeing 777 at 11,000 feet with Mach 0.4. So this is our beautiful aircraft, this airplane. These are his wings, it's useless. Eight 8,000 feet. Let's set up everything here. We need to slow down the airspeed now. Extend the landing gear here. Slow us down. So we have 7 minutes to go for this landing. We are in a good position now for land. We have the runway on this side. So here we are with Mach 0.441. We're gonna use the Lszh localizer also. Keep flying straight. Have like maybe slowing down now the aircraft. A couple of more. Maybe take the control now. I'm gonna use the vol localizer and some flaps here. Slow down the aircraft. So we take the control, maybe disconnect the autopilot here. Have the warning. Going manually now. We have maybe 5 minutes left for this flight. We are already at 5 minutes more. So we keep descend, align with the runway. So we have, you can see where we are right now. Keep descending. We're very low now. You can see we have the landing gear extend. So you're gonna have a nice landing view now. Flying also manually the auto thrust. We have a few more, maybe 4 minutes left. 4 minutes, exactly 4 minutes. So you can see the ILS localizer here. We have the altitude above the ground level, 2,100 feet above sea level, 3,300, and the runway extend line. Here we have the airspeed, the stall speed, the flap position, the reference speed, the ground speed, the terrain warning. We need just to align with the runway. We have maybe a couple more minutes to go. Maybe 4 more minutes to go for this flight, for this video plan. 3 more minutes. So now you can see we are almost aligned with the localizer. This needle and the flight slope is correct. Also the heading here of the runway. We need to go a little bit more to the right. And now we align with the rudder pedal. Advance the thrust levers a bit higher, just to make the maneuver. Very close to the ground. Maybe 2 more minutes left. Two more minutes for this flight. Maybe 1 minute. Here we are, 200. Here we go. We just landed very nicely and very safely. Reverse thrust and brakes. We reverse the thrust here. And we made it. Just in time. Keep slowing down. You can see the aircraft is still configured for takeoff ground. We have the reverse thrust. We're adjusting the landing elevation. No problem. Let's close disconnect. So you can see here you can see the nose wheel here and the landing gear is configured right for this landing. We have no problem. There's no blown tire or broken screws from this landing. Going back inside. T3, 33. We have 33 plus 8, maybe one more minute. A couple more minutes left. So you can see the landing gear and the nose wheel is completely safe after this landing. You can see all landing gear. I'm showing you the nose wheel here. No damage. So this was the Boeing 777. So that was Thomas, the pilot, flying the Boeing 777. 300 yards of this flight. Thank you very much for watching. I'm gonna see you next flight. Bye bye. Thank you very much. Bye. Let me have one more minute for this video game.